Hi, hello there. Welcome to Router on a Stick Inter-VLAN Routing video demo. This is a supplementary video of the Inter-VLAN video lecture. Router on a Stick Inter-VLAN Routing. Let's have a demonstration of a router on a stick. Okay, so we are given these two VLANs here. We are going to create two VLANs, VLAN 10 and VLAN 20. And of course, we have 4 workstations that belongs to each of the VLAN here. So let me start the connection here. Okay, so PC1, let's connect it on port 1 so I can use and assign FA01 to FA05 for VLAN 10. Okay, so next would be, let's connect FA0 to 2. Okay, next would be, for PC3, I'm going to use port 6 to 10 for VLAN 20. So let me connect it to port 6. Okay, and also PC4 to port 7. Okay, so anyway, we can use any number from 6 to 10. Okay, so for the router on a stick, so this approach uses a different path to route between VLANs. So one of the router's physical interface is configured as 802.1q trunk port so that it can understand VLAN tags. Okay, so logical sub-interfaces are created, one sub-interface per VLAN. So each sub-interface is configured with an IP address from the VLAN it represents. Okay, so VLAN members or hosts are configured to use the sub-interface address as a default gateway. So when we assign an IP address here, let's assign that IP address. So for PC1 being part of VLAN 10, that's 172.16.10.1. Okay, so subnet mask is /24. Okay, so as what I've mentioned, VLAN members or hosts are configured to use the sub-interface address as a default gateway. So let me use the last usable IP address. That's 172.16.10.254. Okay, so this is the same with PC2. So let me configure PC2 here. Okay, so for PC2, this is 172.16.10.2. Okay, so this is 255/24. All right, default gateway would be 172.16.10.254. All right, so next for PC3, this is 172.16.20.1. all right, this is /24 also, and then default gateway would be 172.16.20.254. PC4, for PC4, 172.16.20.2. okay, so this is 255 172.16.20.254. all right, so only one of the router's physical interfaces will be used. Okay, so in a legacy inter-VLAN, we use one physical interface per VLAN. Now in a router on a stick, we just need to use one physical interface. Okay, so in this case, let me just use Gigabit Ethernet 00. Okay, and let me connect it to, for instance, Gigabit Ethernet 01 here. Okay, next, so an alternative to legacy inter-VLAN routing is to use the VLAN trunking and sub-interfaces. Okay, so VLAN trunking allows a single physical interface or router interface here to route traffic for multiple VLANs. So we have one physical interface, two VLANs using that interface. Okay, so on the router, we just have to create, okay, so a sub-interface, okay, and each sub-interface is assigned an IP address specific to each subnet or VLAN and is configured to tag frames for that VLAN. So let's have the configuration on the switch first. Okay, so let's start with a switch here. So on the switch, we are going to create two VLANs. So let's start. So enable, configure terminal, host name, say this is switch 1 here. Okay, so create VLAN, VLAN 10, name student, okay, VLAN 20, name faculty. Okay, do show VLAN. So we have created this two VLAN. Next is we need to assign, okay, the interfaces for each of the VLAN. So from the given here, so that would be interface range FA0/1 to 5, switch port mode, okay, access, switch port access VLAN 10. Okay, so same thing with interfaces 6 to 10. So interface FA0/6 to 10. Okay, where's that? So interface range FA0/6 to 10, switch port mode access, switch port access VLAN 20. All right, so let's verify it. So do show VLAN. So as you can see here, we have successfully assigned interfaces 1 to 5 to VLAN 10 and interfaces 6 to 10 to VLAN 20. Okay, so next is we also have to configure this interface here, which is G01 as a trunk. Okay, so that would be interface G0/1, okay, switch port mode trunk. All right, so don't forget to set it to trunk. Okay, so next would be, let's move on to the router. So but then before that, let us test the connectivity within the VLAN. Okay, so at this point in time, PC1, PC2 should be able to ping each other. Let's check that. Okay, so because they are on the same VLAN, same thing with PC3 and PC4 be able to ping each other because they are on the same VLAN. But inter-VLAN communication, so it's a failure because we have not yet configured the inter-VLAN. All right, now let's move on to the router. Okay, so on the router, we need to create a sub interface. Okay, and to do that, so let's have, okay, so this one is no here. Okay, so enable, let's start. Configure terminal. Okay, so host name, this is R1 here, for instance. And we have set interface G00 in this one. Okay, so if you will observe here, that is G00. Okay, so that would be interface G0/0 dot 10. 10 corresponds to a VLAN number. So something like, okay, so interface G00.10, that is for VLAN 10, a sub interface for VLAN 10. Okay, let's assign an IP address to it. So IP address, that would be the last usable IP, 172.16.10.254. All right, 255.255.255.0. Okay, so if you will observe here, you've got notification. Okay, so configuring IP routing on a lab sub interface is only allowed if the sub interface is already configured as part of the IEEE 802.10, okay, or the IEEE 802.1Q VLAN. So before assigning an IP address, so we need first to do the encapsulation. Okay, so if you failed to indicate the encapsulation or to do the encapsulation, this is the error that you're going to encounter. Okay, so that would be encapsulation. Okay, .1Q. Let's choose .1Q, and then VLAN number, which is 10. Okay, So that would be interface G00 slash or .10 encapsulation .1Q. This time we can now assign an IP address. So IP address 172.16.10.254 255.255.255.0. Okay, and then no shutdown. All right, so we have to do the same on the second subinterface. So let's do it. So again, interface G0 slash 0 dot, this time this is for VLAN 20, so .20. Okay, so next would be encapsulation .1Q. Okay, and then VLAN number 20. This time assign an IP address. So IP address 172.16.20.254 255.255.255.0. Okay, so we need some space here. Okay, and then no. Okay, so the no shutdown command here is not necessary because we are on the subinterface. So even though you type in no shutdown, it has no impact because we have to enable the physical interface. So you have to do it on the physical interface, okay, not on the subinterface. So that would be interface G0 slash 0. In here, no shutdown. So that would enable the two subinterfaces assigned to it. Okay, so let's check that. Let's verify. Do show IP int brief. So if you will observe here, okay, so we just have created two subinterfaces which are 00.10 and 00.20. Okay, we assign an IP address to each of the subinterface and we enable the physical interface. So it's up. Okay, so next would be, let's check the connectivity now that we have routing. Okay, so let's check that first on the router. You could have do show IP route. So what you can see here are the directly connected networks, which are the two subinterfaces created on R1. Okay, now let's check the connectivity here. So earlier on, it was a failure. So let's see. It is now successful. All right. So let's have some forward time here. And let's check the Inter-VLAN connectivity using a router on a stick. So PC1 should be able to ping PC3. All right. PC1 to PC4 should also be working. Next, PC2 to PC3 and PC2 to PC4 on the Inter-VLAN. Same thing with PC3 to PC1, okay, and PC3 to PC2 on Inter-VLAN. And the last one, PC4 to PC1 and PC4 to PC2. Okay, so we are done with the configuration of Inter-VLAN on a router on a stick. Okay. Well, if you want to verify the connectivity using ping, you could go ahead and do it here. Or something like, okay, command prompt here, and then you do the ping. Ping, for instance, we're going to ping 172.16.20.1. Okay, so it is successful. All right, so ping 20.2. So you could also do that. Okay, now if you want to verify the path, okay, traverses, so you could have something like, okay, so I want to verify the path from PC1 to PC3, for instance. So you could go ahead and type in tracer, okay, and then the IP address 172.16.20.1, for instance. So as you can see here, it traverses first via the default gateway, which is 172.16.10.254. So this is the subinterface G0/0.10, and it was forwarded then to 172.16.20.1. Okay, so if you want to simulate this, all right, that would also be possible. You just have to go to the simulation here. Let's do that. Okay, so next, let's do the simulation tool. We will be simulating, okay, and we want to see the path from PC1 going to PC4, for instance. Okay, so let's check. From PC1 going to the switch. Okay, next would be going to the router via sub-interface G0/0.10. Okay, and then going back to the switch. Okay, forwarded to 172.16.20.254 and then PC4. Okay, so the response would be from PC4 back to switch via 172.16.20.254. The router will forward it to 172.16.10.254, forwarding it back to the switch and then to the host. Okay, so that's it. And then you've got successful. Okay, so that's the router on a stick configuration for Inter-VLAN.